All right, let's dive in. Today, we're going to crack open the data scientist's toolkit and really demystify this whole world of machine learning. We're going to break down the big ideas and the essential tools you need to know, turning all that complex jargon into something you can actually use. Ready? Let's do this. So, you've probably heard these terms thrown around, right? AI, machine learning, pandas. It can sound like a whole other language. And if you've ever felt a little lost in all the buzzwords, hey, you are definitely not alone. But don't worry. By the time we're done here, you'll see exactly how all these pieces fit together. Okay, first things first. Before we can start building anything cool, we have to lay some groundwork. You can't build a house without a blueprint, right? And for us, that starts with getting one thing crystal clear: the difference between artificial intelligence and machine learning. So here's the easiest way to think about it. AI, that's the big, grand vision. It's the ultimate goal of making machines that can think, reason, and learn just like us. Machine learning, on the other hand, is one of the most powerful methods we have to actually get there. It's not about writing a million if-then rules. Nope. It's about letting the machine learn from data, kind of like how we learn from experience. And this quote right here just nails it. Instead of trying to program intelligence line by line, we feed a machine tons and tons of data and let it figure out the patterns. That whole process of learning from data is machine learning, and it's the engine that powers pretty much all the AI you interact with every single day. So now that we're clear on what ML is, let's get into the first part of our toolkit, the three main flavors of machine learning. You can think of these as the different blueprints or game plans you'd pick for a project, depending on what you're trying to do. First up, and probably the most common one you'll see, is supervised learning. We give the model a whole bunch of data where we already know the right answers. It's exactly like giving a student a study guide that has both the questions and the answers. The whole point is for the machine to learn the patterns so well that it can figure out the answers for new questions it's never seen before. It's incredibly powerful, but the catch is you need all that labeled data to begin with, and getting it can be a real pain. And within supervised learning, it really boils down to two main tasks. If you're trying to predict a specific number, like what's the price of this house going to be, or what's the temperature tomorrow, that's called regression. But if you're trying to put something into a category, like is this email spam or not spam, is this a picture of a cat or a dog, that's called classification. That's it, predicting numbers versus predicting categories. Okay, that's all great if you have a nice, neat answer key. But what if you don't? What if all you have is a big, messy pile of data? Well, that's where our next blueprint comes in, unsupervised learning. Here, we basically throw the data at the machine and say, hey, find something interesting in here for me. No answer key, no labels. It's like dumping a huge bag of mixed up Legos on the floor and telling the computer to sort them into piles that make sense. And trust me, this is used everywhere. Think about how a company like Amazon groups customers with similar shopping habits together. That's clustering. Or how a supermarket might figure out that people who buy bread also tend to buy butter. It's perfect for when you want the data to surprise you and reveal patterns you didn't even know to look for. And now for our last blueprint, reinforcement learning. And this one is a totally different beast. This is all about learning by doing, through pure trial and error. The model takes an action, and if it's a good move, it gets a reward, a virtual treat. If it's a bad move, it gets a penalty. It's literally like training a pet. Over millions and millions of tries, it slowly learns the sequence of actions that gets it the biggest reward. This is the secret sauce behind things like self-driving cars and AI that can beat humans at chess. Okay, so we've got our blueprints. We know the strategy. But what about the actual raw material, the data itself? For that, we need to grab our first power tool from the kit, and that tool is called Pandas. Think of it as your digital workbench, where all the messy, hands-on work gets done. Because let's be real for a second, data you find out in the wild, it is a mess. It's huge, it's got typos, missing pieces, weird formatting, it's just not ready to go. You can't just shovel that raw stuff into your fancy machine learning model and hope for the best. It's garbage in, garbage out, right? You gotta clean it up first. And that is precisely the job of Pandas. It's a library for the Python programming language that gives us something amazing called a data frame. Now, don't let the name scare you. A data frame is basically a spreadsheet on steroids that lives right inside your code. It's built from the ground up to make cleaning, filtering, and organizing massive data sets a whole lot easier. Honestly, you're going to use it in pretty much every single data project. And you know what? Getting started is actually pretty simple. For instance, there's a command, read CSV, that just reads a data file. Boom, it's loaded. Then you can use another one, head, to take a quick peek at the first few rows, just to make sure everything looks okay. And info gives you a quick summary. It's all about getting your hands on the data fast so you can figure out what you're working with. All right, so our data is clean, it's organized on our Pandas workbench, but now what? I mean, staring at a giant table with thousands of rows of numbers doesn't really tell you much, does it? To actually see the story hidden in the data, we need our next tool, Matplotlib. This is our data magnifying glass. Okay, let's make this super practical. Look at this table. We've got a few courses and the number of students enrolled in each one. The data's nice and clean, probably thanks to a tool like Pandas. But just looking at it like this, can you tell me which course is the most popular? Like instantly? You probably can, but you had to scan it, compare the numbers. It took a beat, right? Now imagine this table had 50 courses, or 500. Forget about it. It'd be impossible to see the pattern at a glance. But now, look at this. Bam! It's a bar chart of the exact same data. The answer just jumps right out at you, doesn't it? You don't even have to read the numbers. Your brain just gets it. That right there is the magic of data visualization. And this is exactly why a tool like Matplotlib is absolutely crucial. It's not about making things look pretty for a presentation. It's a core analysis tool. It helps you find trends, spot weird things that don't belong, we call those outliers, and just generally understand your data in a way that staring at numbers never, ever will. Okay, so we've covered the blueprints, the different flavors of ML, and we've looked at the essential tools, our workbench and our magnifying glass. Now let's put it all together and see what a real machine learning workflow actually looks like from start to finish. It almost always follows these 5 steps. You start by collecting data. Then comes step 2. And this is a big one, pre-processing. This is where you bring out your digital workbench, Pandas, and you clean and shape all that messy data. Only then are you ready for step 3, training the model using one of those blueprints. After it's trained, you have to check its work. That's step 4, model evaluation. And that's where our magnifying glass, Matplotlib, is perfect for seeing how it did. And finally, if it all checks out, you deploy it into the real world. So let's do a super quick recap of the whole toolkit. Remember, AI is the big goal. Machine learning is the method to get there. ML comes in 3 main flavors: supervised, when you have an answer key, unsupervised, when you don't, and reinforcement, which learns by trial and error. To handle the data, you use Pandas. That's your workbench. And to understand the data, you use Matplotlib. That's your magnifying glass. And there you have it. That's the basic toolkit. It's the foundation for pretty much everything in data science and machine learning. You now get the blueprints, you know about the workbench, and you have the magnifying glass. So the only question left is, now that you've got the toolkit, what problem are you going to solve first?